After a surface nuclear burst, data must be collected and reported so that a fallout prediction can be made. Specific units are designated to carry out these functions. Normally, these are headquarters of field artillery battalions or air defense artillery batteries and battalions, although other units may also be designated. These units are authorized a number of instruments capable of making the necessary measurements for nuclear burst reporting. This aiming circle, for example, is a good way to determine azimuths. The M2 compass is another convenient measuring device, especially for vertical angles up to 1200 mils. The battery commander scope, because of its magnifying power, is suitable for accurate sightings up to distances of 6 miles. Standard issue binoculars, too, are good for accurate long-distance measurements. Artillery pieces, such as this 105mm howitzer, are exceptionally useful because of their precision sights. These can measure both horizontal and vertical distances. Air defense radar may also provide essential nuclear burst data. However, other methods may be used by any designated unit or individuals within these units. These men will receive special training. When the flash of a nuclear burst is seen, immediately take cover, whether you're on a front line or in a rear area. Start counting the seconds between the time you see the flash and the time the shock sound wave reaches you. This is the first step in the NBC-1 nuclear reporting system. Use your watch. If you have no watch, count flash to bang time orally. Until the shock sound wave passes, remain covered. Do not look at the fireball. The brilliant light of the burst or the light immediately thereafter can damage the eyes. The shock sound wave alone is powerful enough to cause casualties. When the sound of the explosion is heard, quickly determine the flash to bang time and then record it. The second step in the method is to observe the nuclear cloud and determine the type of burst, either air, surface, or unknown. Now record the type of burst and the time the burst was observed. The third step is to obtain the azimuth from your unit's position to the nuclear burst cloud. Now record your unit's location. This with flash to bang time, the azimuth to the cloud, and the width of the nuclear burst cloud determine the nuclear yield of the explosion and the location of ground zero. All of this data your unit has gathered is of immediate concern to the battlefield commander. The information should be forwarded as quickly as possible through command, intelligence, or artillery channels to the CBR element at division headquarters. At the CBR element, the report is integrated with other information to establish an initial estimate of fallout hazard and nuclear damage. The data reported by your unit is recorded at the CBR element using the format for the NBC-1 nuclear report. Five minutes after burst, the width of the nuclear burst cloud is determined. This may be done by using the aiming circle. This cloud measurement, when combined with flash to bang time, provides a means for estimating nuclear yield. It also serves as confirmation of the unit's initial report. Once the findings have been recorded, make a final report through channels to the CBR element. The CBR element records the new data with the original report. The information is transmitted and recorded according to the standardized NBC-1 nuclear report format. Let us study the elements that make up the report. Alpha. The strike serial number is an identification code assigned by the CBR element to each nuclear burst. This information is not normally available to the soldier in the field. Bravo. Position of the observer. The reporting unit's position may be given as actual location or map coordinates. Charlie, azimuth of attack. The direction of the attack read clockwise from grid or magnetic north. The report will specify which, and whether in mils or degrees. Delta, date and time of attack. Time must be specified as to whether local or Zulu in accordance with unit SOP. Echo, illumination time. The time in seconds between the first awareness of the detonation until the brilliant white glow fades. This information is useful only when no other data can be obtained, as in the case of a night attack. Foxtrot, the location of the attack given in either map coordinates or locale. Specify whether this is estimated or actual ground zero. Golf, means of delivery, the method used to deliver the warhead to the point of detonation. Hotel, type of burst. This letter item is always reported. If the type of burst is not known, report it unknown. Here are the three most common types of burst: surface, low air, and high air. This is how they look about 20 seconds after the explosion. The high air burst cloud has little or no stem and is shaped somewhat like a donut. The low air burst cloud often has a pronounced stem, which is similar to the stem of a surface burst cloud. When trying to differentiate between the two, look at the base surge. Generally, a low air burst has less base surge than that of a surface burst. Also, the surface burst cloud is usually darker and has greater density. There are times when a low air burst cloud can be observed before its stem forms. In such cases, the observer can be sure he's watching an air burst, not a surface burst. Remember, try to distinguish the type of burst as soon as possible after the sound shock wave has passed. The next line on the report is Juliet, flash to bang time. This is the time in seconds between the brilliant white flash and the sound of the detonation. Kilo, crater. If ground zero can be viewed, report the absence of a crater or its presence and diameter. Lima, nuclear cloud width. This measurement is made 5 minutes after the burst. The measurement may be taken either in mils or degrees and so stated in the report. Line Mike is reported only if line Lima was not measured. Line Mike is the measurement of the angle to the top or bottom of the stabilized cloud in mils or degrees. It may also be the height of the cloud top or bottom in feet or meters. We will measure the bottom of this cloud because it is more visible. However, measurement of the top is preferred. State whether top or bottom, and units of measurement. This measurement is made 10 minutes after the burst. The nuclear burst cloud continues to grow for about 4 to 14 minutes after the burst, depending upon yield. This diagram shows the relative growth of a cloud at 2-minute intervals. Notice that during the period from 7 to 10 minutes, the cloud's height does not increase, but the width does. This means the cloud has stabilized. Although actual NBC-1 report forms vary, remember they will contain the same essential items of information. The information for all the lines in the NBC-1 reports may not always be available. In this event, report only the lines for which there is data. Now let's look at a burst and see how the CBR-NCO of a rifle company would react to it by performing each step in the NBC-1 nuclear reporting system. Take cover. Do not look at the burst. Immediately start the flash-to-bang time count, the time it takes for the shock sound wave to reach the unit's position after first seeing the flash of the explosion. Count off the seconds orally, as this man is doing. 1001, 1002, 1003, and so on. A wristwatch or stopwatch can also be used effectively for the count. The light of the burst may still be a hazard to the eyes, and the shock sound wave is moving out at nearly 800 miles per hour. Therefore, remain under cover until the wave passes. When the wave does pass, record the flash-to-bang time. After flash-to-bang time has been recorded, determine the type of burst, and then measure the azimuth from your unit's position to the point of attack. This information will also be recorded and immediately reported along with your unit's location. Remember, 5 minutes must elapse between the time of burst and the measurement of the cloud width. It must be emphasized that a 5-minute interval is an absolute necessity when making this measurement. This new data must also be recorded and immediately reported. At the CBR element, the report is quickly analyzed to come up with a nuclear yield estimate and the location of ground zero. The NBC-1 report offers a quick means of computing nuclear yield estimates which are indispensable in predicting the extent of fallout hazard and nuclear damage, as well as the intentions of the enemy. Strict adherence to the procedures established for the NBC-1 nuclear report will assist the commander and his staff in evaluating the effects of the nuclear attack. Accurate reporting contributes vitally to the successful completion of a unit's mission.